Okay, returning to the problem before this one, just to illustrate what I'm talking about when I say that you can use intuition and understanding, a rigorous understanding of velocity and acceleration and uniformly accelerated motion to solve the problem we had previously. Okay, you have, remember, v was 2 meters per second at t equals 5 seconds, 8 meters per second at t equals 10 seconds. Well, this means that velocity changed by 6 meters per second while the time went from 5 seconds to 10 seconds. The time changed by 5 seconds. So during this interval, delta v is 6 meters per second, delta t is 5 seconds. You don't need a formula if you understand what acceleration is to say that, okay, well, the average acceleration is then delta v over delta t, change in velocity, divided by the change in time, or the rate at which velocity changes with respect to time, which corresponds to derivative. Okay? We don't need calculus to do this. Delta v over delta t is 6 meters per second over 5 seconds, or 1.2 meters per second squared. And that is the acceleration. Since acceleration is uniform, the acceleration at any instant equals the average acceleration on that interval. So we have then, we could write v of t equals v of 0 plus 1/2 at squared, which is just v of 0 times, and I wrote something wrong here, 1.2 meters per second squared times t, since that's our acceleration. And now we could plug in, for example, v of 5 seconds would be 2 meters per second. So if we plug in 5 seconds for t, set that equal to 2 meters per second, we can do v of 0, then we never needed to use simultaneous equations. However, we can do even better than that. We don't have to write any equations. We can just use what we understand about uniform acceleration. Okay? So here from t equals 0 to t equals 5 seconds, for the interval from t equals 0 to t equals 5 seconds, we can calculate the delta v, assuming that we have this uniform acceleration. We just multiply the 1.2 meters per second squared by the 5 seconds that elapses during this interval, and we see that the change in velocity is going to be 6 meters per second. If the velocity changes by 6 meters per second and ends up at 2 meters per second, a little bit of thought and visualizing the number line tells you that you must have started at -4 meters per second. So we can just say, of course, that v of 0 is 6 meters per second less than it was at t equals 5 seconds. And actually write it out more formally, but we don't really need to do that. Okay, it should be pretty obvious. And then of course, everything can be checked, because now we know that v of 0 would be -4 meters per second, and you can then plug in 5 seconds and 10 seconds into the resulting equation and see that you do get these velocities. You see, this is all reasoned out by very, informal. A formal solution is simultaneous equations and so forth. And this can actually be a formal solution also, if you state all the conditions very clearly, state everything that I did. This kind of reasoning leads you to understand uniformly accelerated motion. The equations of motion don't. Okay, that's all there is to it. And you want to be able to use both. You want to be able to use the equations, and you want to be able to reason things out using something very much like common sense that invokes a real understanding of what's going on. Okay, anyhow, there it is.